Welcome to The Debate. Today we are dissecting what might be the single most contentious event in modern history. We're looking at the Apollo moon landings. Between 1969 and 1972, the official story is that NASA sent 12 astronauts to the lunar surface and brought them all home safely. It's framed as the absolute pinnacle of human engineering. But there's a shadow narrative, one that's persisted for over 50 years, that suggests this was all just the greatest deception ever orchestrated.
Right. A Cold War theater production. It really is the ultimate test of evidence versus perception, isn't it? On one side, you have this geopolitical need for a win. You have the limits of 1960s technology and, some genuinely confusing visual anomalies. On the other, you have forensic data, rock samples, and the laws of physics. So we're here to ask, was Apollo a triumph of aerospace engineering, or was it a masterpiece of special effects?
I'm taking the role of the skeptic today. I'm looking at this through the lens of motive and, frankly, visual inconsistency. When something looks too good to be true and the government has everything to lose if it fails, I think we have an obligation to ask if we're being lied to. The narrative feels a little too clean.
And I'll be playing the investigator. My job is to strip away the emotion and the politics and just look at the hard data, the engineering constraints, the chemistry, and the physics that, you just can't forge. I'm going to treat the landing not as a historical story, but as a crime scene that needs to be forensically audited.
Okay, so let's start with the motive, because without that, none of the conspiracy makes any sense. The year is 1969. The United States is bleeding morale. The Vietnam War is a disaster. Civil rights protests are rocking the country. And most importantly, the Soviet Union is absolutely crushing us in space. They beat us to a satellite with Sputnik. They beat us to a human in orbit with Gagarin, the first spacewalk. President Kennedy promised the moon by the end of the decade. If NASA fails, American exceptionalism takes a potentially fatal blow. The incentive to fake it, to guarantee a win, was, astronomical.
I don't dispute the motive at all. The desperation was real. The U.S. government absolutely needed a win, but motive isn't method. My position is that while the administration certainly wanted the win, the forensic reality of 1969 shows that faking the landing would have been technically much, much more difficult than actually doing it. We're not just trusting a NASA press release here. We are trusting the behavior of light, the chemistry of rocks, and, the real-world limitations of data storage that existed at the time.
These beautiful high-definition images that are supposed to be from a vacuum 240,000 miles away, but when you look closely, the physics just seem off. The most famous example, the one everyone points to, is the flag. We have clear footage of Armstrong and Aldrin planting the stars and stripes, and it's waving, it's rippling. There is no atmosphere on the moon, no air means no wind. So, explain to me how a flag flutters in a vacuum without a studio fan blowing on it.
This is the classic gut check problem. We're so used to seeing things move in an atmosphere that our intuition, it just misleads us. Here is what's actually happening physically. The flag assembly wasn't just a piece of cloth on a vertical pole. NASA engineers knew there was no wind to hold the flag out, so they designed a telescoping horizontal crossbar along the top. It was sort of like an inverted L shape.
Sure, that keeps it extended, but that doesn't explain the movement. In the footage, it is flapping back and forth.
It moves because the astronauts are moving it. To get the flagpole into the ground, which was a lot harder than they expected, they had to twist the vertical pole back and forth to sort of corkscrew it into the lunar regolith. That twisting motion sent kinetic energy up the pole and into the fabric.
Right, but the motion continues after they stop touching it. That's the issue. If I shake a flag here in the studio and stop, the flag stops almost immediately.
And that is exactly the point. On Earth, if you wave a flag and let go, the air resistance, the drag, damps that energy almost instantly. The air stops the motion. On the moon, there is zero drag. So the kinetic energy imparted by the astronaut twisting the pole has nowhere to go. The fabric just keeps swinging like a pendulum. It's not rippling because of wind, it's rippling because of inertia and a total lack of friction. Honestly, if that were filmed in a studio with air, the flag would have settled in seconds. The fact that it swings for so long is actually proof of the vacuum.
Okay, so you're saying the wave is just trapped energy that can't bleed off. I can accept that as a possibility. But let's look up. In every single photograph taken from the lunar surface, the sky is pitch black, a void. Now on Earth, the atmosphere scatters sunlight, which turns the sky blue and hides the stars during the day. But on the moon, there is no atmosphere. You should have a front row seat to the entire galaxy. The stars should be blindingly bright, yet the photos show nothing. It looks like a black velvet backdrop in a studio. Why didn't the cameras capture the cosmos?
This comes down to the dynamic range of film and a concept in photography called the Sunny 16 rule. You have to remember the environment. They're standing on the daylight side of the moon. The sun is unfiltered and incredibly intense. The ground is gray, reflective dust. The astronauts are wearing these brilliant white spacesuits. I mean, it is dazzlingly bright.
So it's an exposure issue?
Exactly. To take a picture of a bright white astronaut in direct sunlight without just blowing out the image and making it look like a white smear, you have to use a very fast shutter speed, like around 1/250th of a second, and a very small aperture, like f11. You are essentially squinting the camera. Stars are just faint little points of light. At those settings, the film simply isn't sensitive enough to register them.
But shouldn't a camera in space be able to see everything?
Think of it this way. If you go to a football stadium at night, under those massive floodlights, and you take a picture of the quarterback on the field, is the sky behind him full of stars? No, it's pitch black. The camera is exposed for the brightly lit field, not the faint stars light years away. If NASA had slowed the shutter speed down to capture the stars, the astronauts would have been completely overexposed, just glowing white blobs.
That makes sense. But let's talk about the lighting on the ground. This is one that really suggests a studio setup to me. You have the sun, which is one light source, millions of miles away. That means all shadows should be parallel. But you look at the photos. The shadows diverge. You have an astronaut's shadow going one way and a rock's shadow going another. Diverging shadows mean a local light source, a spotlight.
That's a valid intuitive leap, but it fails on two geometric points: topography and perspective. First, the lunar surface isn't a flat parking lot. It's rolling, uneven terrain. If a shadow falls across a rise or dips into a little crater, it distorts. It looks like it's changing direction, but really it's just the ground changing shape. But more importantly, it's perspective. Go stand on a railroad track. The rails are parallel, right?
Sure.
But if you look into the distance, they appear to converge at a vanishing point. Shadows in a 2D photograph do the exact same thing. They are parallel lines receding from the viewer, so they appear to converge or diverge depending on the camera angle. That's not a lighting error. That's just how 3D space translates to a 2D image. If there were multiple studio lights, you wouldn't just see diverging shadows. You'd see multiple shadows for every single object. And in the Apollo photos, every object has only one shadow.
I want to press on one more visual oddity before we move on: the crosshairs. These Hasselblad cameras had these little fiducial marks, little crosses etched into the glass plate between the lens and the film. In several famous photos, you see a white object like part of the lunar rover, and the black crosshair seems to disappear behind the white object. The white blots out the black line. That implies the rover was pasted on top of the image later. It looks like bad compositioning.
That is a phenomenon called halation or bloom. It's a chemical reaction in the film emulsion itself. When you have an extremely bright, saturated white object like the sun hitting that white rover, the light is so intense that it doesn't just expose the silver halite grains it hits. It actually bleeds into the adjacent grains. The brightness literally spills over the boundaries, and this oversaturation just obliterates the thin black line of the crosshair. It wasn't pasted over, it was washed out by the sheer intensity of the light.
You have answers for the optics, I'll grant you that. But visuals can be debated all day long. Let's talk about something that physics suggests is a hard stop: the environment. Specifically, the Van Allen radiation belts. These are zones of highly charged particles trapped by Earth's magnetic field. NASA admits they exist. They are essentially a wall of radiation. You're sending human beings through a zone of lethal energy in a ship made of aluminum alloy, basically tinfoil. How do they not come back with acute radiation sickness? Or dead?
Lethal wall is the common misconception here. The Van Allen belts are dangerous, yes, but they aren't a solid barrier like a brick wall. They have varying densities. NASA actually plotted the translunar injection trajectory specifically to bypass the most intense inner regions. They threaded the needle.
But they still had to pass through them. You can't avoid them entirely.
True, but speed is the key factor. The spacecraft was moving at nearly 25,000 miles per hour. The total transit time through the belt was roughly 60 to 90 minutes. It's the difference between walking slowly through a bonfire and running your finger quickly through a candle flame. The dose is determined by exposure time. The aluminum hull actually provided adequate shielding against the specific type of particles in the belts.
Adequate is a pretty vague term when we're talking about radiation that can rewrite your DNA.
Well, we have the specific numbers. The astronauts wore personal dosimeters. The average total mission dose for the Apollo crews was about 1.8 millisieverts. To put that in context, a lethal dose is over 1,000 millisieverts. 1.8 is about what you get from a CT scan. It's not zero risk, it's definitely higher than staying on Earth, but it is nowhere near a lethal dose. The microwave oven theory just assumes they hung out in the belts for days, but they punched through in minutes.
Okay, so if we accept the radiation wasn't immediately lethal, we still have to deal with the production quality. The footage looks dreamy, low gravity, slow movement. The theory is that Stanley Kubrick, who had just made 2001: A Space Odyssey, directed the whole thing. The look of moonwalking was achieved by filming in a studio and just slowing the footage down. You film at high speed, play it back slow, and suddenly a jump looks like a float. It's a simple camera trick.
I love the Kubrick theory because it's culturally fascinating, but it just crashes into a hard technological wall: data storage. This is the critical insight. Apollo 11 broadcast 143 minutes of live footage.
Right, and they had plenty of film reels in Hollywood.
Film, yes, but you can't broadcast film live. You need video. In 1969, video was stored on these huge magnetic disc recorders. The absolute state-of-the-art machine could hold about 30 seconds of slow-motion video. That was the physical limit of magnetic storage at the time.
Wait, only 30 seconds?
That was it. They used those machines for instant replay in sports, which was a brand new thing. To fake a continuous 143-minute broadcast in slow motion, you would need a storage medium roughly 3,000 times larger than anything that existed on Earth. We are talking about technology that wouldn't be invented for another 40 years. You can fake a set, but you can't fake data capacity that doesn't exist. It was physically impossible with 1969 hardware.
That is a strong point on the broadcast duration. I hadn't considered the storage limits, but let's stay on the physics of movement. The dust. Skeptics point to the way the dust moves under the rover wheels. It doesn't look like it's floating in a vacuum. It looks like dirt getting kicked up by a buggy in the desert.
Actually, the dust is the one thing that is mathematically impossible to fake. If you look at the Grand Prix footage from Apollo 16, where they're driving the rover, the wheels kick up these rooster tails of regolith. On Earth, if you kick up dust with a Jeep, what happens?
The air catches it, it billows, you get a cloud that just hangs there.
Exactly. Turbulence. But in the Apollo footage, there is zero billowing. Every single particle, from the dust specks to the pebbles, travels in a perfect, distinct parabolic arc. It goes up and comes down in this clean geometric curve. There's absolutely no air resistance affecting it. And physics analysis of that footage allows you to calculate the gravity based on the rate of fall.
And the math checks out.
Perfectly. The dust falls at an acceleration of 1.62 meters per second squared, which is exactly lunar gravity. To fake that on Earth, you can't just use slow motion because the air would still make the dust swirl. You would need a vacuum chamber the size of a football stadium to drive the rover in. No such chamber existed then, and it doesn't exist now. The behavior of that dust is a fingerprint of a vacuum environment that you simply cannot forge.
The parabolic arc is compelling. It's hard to argue with geometry. But let's get to the physical evidence. You said there are smoking guns, items that physically exist. Photos can be doctored, tapes can be looped. What do you have that I can touch?
The most undeniable piece of hardware is the retroreflectors. Apollo 11, 14, and 15 left behind these arrays of corner cube prisms. They're basically high-tech mirrors designed to bounce light back exactly where it came from. Today, right now, independent observatories, not NASA, But places like the McDonald Observatory in Texas fire lasers at those specific coordinates.
And they get a return signal?
They get a precise return signal. They measure the time it takes for the light to come back and use that to calculate the distance to the moon down to the millimeter. Those reflectors are still sitting there. Unless you want to argue that we secretly sent robots to place them, which would have been a massive feat in itself, humans put them there.
I suppose robotic placement is theoretically possible, though difficult. What about the rocks? We have 382 kilograms of so-called moon rocks. But rocks are rocks. How do we know they aren't just meteorites picked up in Antarctica?
The chemistry makes them unique. First, they are anhydrous, which means they are bone dry. They contain absolutely no water in their crystal structure. Earth rocks, even from the driest deserts, have some hydration. But the real tell is the zap pits.
Zap pits?
They're microscopic craters. On the moon, there's no atmosphere to burn up dust, so tiny micrometeoroids hit the surface rocks at 10 kilometers a second. It creates these tiny glass-lined pits on the surface of the rocks. On Earth, those particles just burn up in the atmosphere. You cannot reproduce zap pits here. And what's more, the rocks are loaded with helium-3, an isotope implanted by the solar wind. Our atmosphere blocks helium-3. You literally cannot find a rock on Earth with that chemical signature unless it came from space.
Okay, I'm going to play my final card. The big lie. You say the rocks are real, the lasers are real, but we are talking about the U.S. government, the CIA. The stakes were winning the Cold War. If the alternative was national humiliation, wouldn't they find a way to manufacture this evidence? To bribe the scientists? To switch the rocks?
And that brings me to the geopolitical checkmate, the Soviet Union. You have to remember, the Soviets weren't just watching, they were analyzing. They had their own massive tracking network in the Crimea. They were tracking the telemetry and the radio signals of the Apollo missions in real time.
So they would have known where the signal was coming from?
Immediately. It's called the Doppler shift. As a spacecraft moves away from Earth, the frequency of its radio signal changes. If the signal had been coming from a studio in Nevada or even a satellite in Earth orbit, the Doppler shift would have been completely different than a signal coming from a ship moving toward the moon. The Soviets could verify the trajectory just by listening to the radio waves.
And they stayed silent?
That's the key. The Soviets had every single reason to expose the lie. It would have destroyed American credibility for a century. It would have handed them the Cold War victory on a platter. But they didn't. They congratulated us. The fact that our sworn enemy, who had the technical means to catch a fraud, confirmed the landing is arguably the strongest evidence that it happened. They checked the math, and the math worked.
That's very difficult to get around. The silence of the Soviets is louder than the shouting of the conspiracy theorists. If they couldn't debunk it, it's hard to believe a guy on YouTube can.
Exactly. And finally, you just have to consider the organizational scale. There's a concept called Grimes formula, developed by a mathematician to calculate the probability of a conspiracy leaking based on the number of people involved.
And Apollo was massive.
It employed roughly 400,000 people. Engineers, seamstresses, fuel technicians, caterers. According to the probability models, a secret held by that many people would inevitably suffer a leak, a whistleblower, a deathbed confession, a misplaced document, within about 3.68 years.
And here we are, more than 50 years later.
And not one single verifiable whistleblower from inside the project has ever stepped forward to say it was faked. Maintaining perfect silence among 500,000 people for half a century is, well, it's statistically impossible. The sheer human skill of the project makes the hoax theory untenable.
I have to admit, when you stack the evidence, the dust physics, the film storage limits, the chemistry of the rocks, and the Soviet verification, the hoax narrative starts to look much flimsier than the aluminum walls of the LEM.
The visual anomalies are puzzling at first glance, but the forensic engineering really does answer them.
Skepticism is healthy. It forces us to prove our history. But in this case, the complexity of the truth, that we actually strapped 3 men to a giant bomb and shot them at a rock in the sky, is far more interesting and, frankly, terrifying than the simplicity of a studio set.
A terrifying triumph. We will leave it there for today. Thank you for listening to The Debate.
Keep looking up.